Yeah, so one of the things is like in terms of having graphs, you showed those like threat nodes, and say for each one of those threat nodes represents like a single attacker. Wouldn't that like exponentially like blow up in terms of the number of nodes you have in your graph?
So which one? You are talking about
Yeah, that one, and then you can even look at that one too, like where the attackers are acting as nodes. If those attackers represent specific like IP addresses, for example, then could that blow up like in terms of the graph sizes?
it depends on your hardware, right? And like imagine that I would say the network itself is always bigger than the number of attackers, because usually there are lots of layers of controls before reaching that node that drops. Like there are controls that like drop 99% of the attacks before even reaching to us. Like then by request it just drops, and I'm sure like all the banks have that. Right? So no, I would say like the network, like if something blows up the system, like bigger companies like banks was like even like a small size banks, not the banks that big as obviously TD or Scotiabank. It's a small size bank. The network itself is more complicated than the number of attackers.
You briefly mentioned this, but you should be really lucky to have a complete view over your black graph most of the time, right? Like most of the time, you only have a subset of the graph, the view over a subset of the graph. So is there a method that you can build with a somewhat confidence the rest of the graph that you don't see?
I don't know.
I can guess. I don't know if it would work.
Yeah.
So this is just throwing something
just
completely insane out there. Recently, there's been a lot of work on. If you have ever heard of variational autoencoders,
Yeah.
where you're learning the latent distribution that describes the data, and then you use it to generate new data. You can do that with graphs, so you could generate a new graph. You could then maybe figure out like. You could obfuscate portions and then see
I'd
like
say
given that portion. But
very
yeah, I don't know. I think it probably wouldn't work.
yeah.
But
there's been research on it, you're saying?
yeah, there's research on graph generation, but I don't know if that really helps with partially observed graphs. The other thing that maybe I would look into, which again might be a little bit on the crazy side, but Palm to Peas. So this is in, it sounds like a ridiculous name, but it's in reinforcement learning, and it's partially observed Markov decision processes. So in that sense, it's agents in an environment that is, they're not observing the entire environment, and they have to make inferences based on that environment. So that's why it's called partially observed. And so there could be some solutions in the literature there.
I would say I would think about it, but we've worked with the partial view graph before, and the result was surprisingly successful. Yeah, it depends on what problem you might solve. Like again, like as I mentioned, for what was that? For anti-money laundering, right? Yeah, if you take half of the graph, but you see the money comes back, you say, okay, this person is doing something shady, right? And you have to flag them, right?
So
It's yeah.
could you create like a pseudo node where this node represents the unknown, and everything went out to the unknown, and then something came in from outside?
You can do that, and if anything you have, like for example, if you have, actually that's a good idea, very good idea. I know IBM did that for anti-money laundering techniques they were working, I think, or something did that. So for example, you say, okay, any money went to Germany, it's this node. Any money went to US is this node. Any money went to Like if you know that like for like different countries, you just put the nodes and then give a risk to the nodes then. So for example, you would say, hey, these set of countries are riskier in terms of anti-money laundering. We have a higher risk than sending money to some less riskier. And that's how you like complete your view.
You could also possibly infer edges between, say, so you have Germany and you have France, but maybe, because they're in the Euro, they're in the European Union, probably flow of money is a lot easier between those two countries than it would be to, like, say, China. So you could infer maybe some edge weighting as well if that was necessary, saying like the likelihood that it's going to flow from here to there.
Some countries money interaction is bigger, and you can based on. It's always like, although it's supposed to be automatic, but you always bring your bias to the system. I would say people send money in this specific set of countries back home, so that's why we see so many like nodes goes to a specific countries rather than like richer country. I would say it's very like.
Source code as a graph, like either for parts that you don't have access to or different levels of abstraction. You just introduce a new node and you learn the representation of that node based on the context that you have, and then use that as with your embedding vectors.
Personally, for me, next time think about before say you don't know. Like actually, like.
I just come up with the insane ideas.
No, that was really good idea. Like that's actual idea. How bright he is, right?
So we just got it raised, right?
He always. If I want to raise him based on that info like that, like I have to keep him like. It's a 1 cent per idea at this rate. Oh, thank you very much.
Oh, yes. So I have a question.
Seriously?
Yeah. Give me the raise and I don't have a question. It's graphs sound amazing, and it seems like you need powerful resources to compute graph problems. Is that all you need? If you have powerful resources, can you solve any graph problem?
No, I don't think so. That's a hard question. Why are you asking a hard question? And no, I don't think so. Like it's not. It depends. Like if you have super powerful like sci-fi level, probably. I don't know. Like in the futuristic data, like it says like you can't solve everything with graph, but I don't think we don't have enough powerful model like computers, at least even Facebook. Like that's why like social media networks are still like people working on it, right? Other if we had enough powerful, because
Complexity problem.
the complexity is massive, right?
So,
And sorry, if you have enough power to make the whole graph, you need like much powerful to analyze that graph. It's become like, and you can build a graph, but you need with all your resources. But the complexity of calculating relation between graphs, like nodes, it's just massive.
so some algorithms can be really efficient, but maybe not very accurate. But some can be very accurate, but just take forever.
Yeah. You will see it tonight.
I don't know much about graphs, but I mean what I notice here is that there's always kind of a unidirectional way, in the sense that, for example, Billy follows Ruth doesn't follow Heather, and so on, right? I mean, the idea is someone follows somebody and the other one doesn't follow them. Or like in the money laundering, right? Okay, A is transferring money to B is transferring money to C, and so on, right?
Yeah.
But the idea is we know that the action is sending money, or the action is following somebody on Twitter or following you back. But in so many problems, things are more complicated. And even the action is not none, right? Like, and maybe there's so many different actions that I mean, in fraud, for example, yes, maybe the action is this person didn't pay money for that, but You know what I mean? Like the connection is a bit more harder to figure out, right?
So it depends. I brought it here. I take it from it. It's kind of sample of fraud in insurance, right? The question you're asking, I think, is mostly finding relationship between data, right?
Right.
And then the other thing is what type of the information you want to put as a node, and what type of information you want to put as edge, right? You always have to, like, this is, I don't know if there is an autograph model or not, but this is some input you give it as an input. I want, like,
So is it the user who is the one who will be defining those nodes
Yes.
and edges? And
you give an input that you give some sort of relation between the nodes. You create the graph, right?
Right.
With any information you have, right? And it depends on you to define connections. Like the whole idea is we have two entities. It could be anything. It could be person and object. It could be different nature, but
Right.
they're somehow connected or disconnected. It could be disconnected. There could be like no connection. But if there's like there is no connection at all between the entities, it's like you might not miss it. Can I stand up? Sorry.
Oh, before you do that, really just made a point. Some of the cells in the collab may be running very, very long time. Like
I know. Yeah.
So-
There's one that actually has a warning that says don't run it. So-
as long as you're aware of it. Okay.
I appreciate that. I remember that. Okay, I'll take it as a last question. We'll start running some of them because this is something we were mentioning that it's a graph problem.
Okay.
And yeah, I'm sorry, Billy. I know. Like, please read the description. Some of them are literally says do not run.
Run at your
So-
own risk.
This could happen. So, for example, you note as a person, as a house. Literally, it's hard.
I mean, I wouldn't want to live there, but it's fine.
And as, I don't know,
A car? Okay, sure.
like these are your notes. When was the last time I drew something?
The wheels are on the top.
Yeah. And then like keep. So one thing can happen is when you define relations, right? Something like that might show up. It probably shows up. So this person is connected that this one has this car. This car are similar to each other for some reason. This person has this one. This car has related to this house as well. And I want to create this like or something. Did I? Let's miss something. And this connected to this, right? So it's not really easy to find a relation between person A and person C, right? But if you follow the graph, you will see, okay, this person through the connection to the house, through the connection to this car, through the connection to this car, through the connection to this house, to this person are connected. And this is the beauty of the graph, right? It can show you the complex connectivity that you can not easily see.
Right, but I am as a user, I'm the one who defining those relations. Like, I am-
This relation, yes. But relation between these two, you don't need to define it. It shows up as, like, it might be so complex. I'm just like coming out with the idea, right?
It's not necessarily the definition. It's coming from the data that exists. Those
Yeah.
blue edges coming from the existing data. Right?
Yeah, this one's the blue, like all the lines and stuff. There's some sort of relationship between them, right? And you
Yeah,
define that some sort of relation.
So graph is good for those hidden relations. It's good for to figure
Like,
out.
yeah, it shows the complexity, right? Like, but you have to define that that some sort of connection, and then dig out to see what you can
Right.
get out
And
of.
so what's the reusability So like, where does it come? Okay, so now we define the graph, and then there are some hidden connections, and then how can we reuse it? Like, what is the application here? Or, like, how can you take it to the next level to figure out what?
So it could be live. Like with the adding, like you can add
dynamic?
with the, yeah, it could be dynamic. With the information gets added, we can make it bigger, and then like at some point drop some of these. Right, so you could add information here and drop some of them. It depends on what you want to use it for, right? It's good for showing the community. It's good for showing the interest between people, right? If people, like, it's a kind of recommendation system. Like, let's talk about a little bit. What did I do?
I think it's just your laptop went to sleep.
Can you just move the mouse?
I don't think they need it. Oh, that. Sorry.
Battery?
No,
Oh.
I think I took it this one off.
Oh,
So
I'm still getting the signal.
I'm just going to say something while you fix that. Okay. Another thing that we're not covering today, but is often used a lot, is multiple edges. So you can have lots of different edges. So in this case here, this could be that those two people up there are work colleagues, but they're also brother and sister. And maybe you could have another relationship, like, you know, school friends, or like went to university together, or play in the same soccer team. You can add all of these things. You can create all of these edges, and there can be multiple edges between people, and that can get very, very powerful very quickly. So yeah, reality is going to dictate the structure of the graph, but also you can decide what those edges can be and how many edges there can be per
And what do you want
two
to
nodes.
use it, right? So at some point you would have, so you want to decide on fraud, on community, on recommendation, on what, and it gives you that information. Like it kind of tells you these two people, these three people are interested in this car, for example, all of them. It's not, it doesn't show, I was looking at the graph, it doesn't show like that, but it could be. Like anybody has this house, probably wants this car and this car as a second car, right? I just come up with it right now. Like it's not the graph I know of or something. I'm just coming up with the example on the fly. So.
But also, like going back to your question earlier, where you were asking, you know, is it generalizable? How do I reuse this? Like a lot of the time, there's a lot of algorithms that have been developed that are to deal with specific graph problems, and Sahara is going to teach you some today. So an example would be PageRank.
Yeah.
And that's basically what made Google all its billions initially, or at least definitely got its foothold in before it could make its billions in advertising. It's just PageRank.
Okay.
And that's
It's a
United
graph.
States,
And then
right?
you use the same model in fraud, in web spam detection, and so many other things, right? It's, you can use the same connectivity relation and relation between the models in different area.
physics. energy
Physics,
transfer,
yeah.
anything.
Can we say that if something is not connected to anything, this is an anomaly? Because like now all the connections are drawn, maybe some of them are hidden, that's fine. Can we say like this is the mainstream, and anything that is not connected to anything, this is a way to
Probably.
Yeah, I mean, there's metrics that you can look at, is connectivity and things like that, right?
Yeah.
Sorry.
So there's, no, please, go ahead. I'm not. So one of the metrics you can see, you can talk about is, as he said, it's actually called connectivity. It shows how things are connected together and cluster things together. Right, so it would say, like, 10,000 objects are here, and there is one object here two objects here that has no connection to whatsoever. So this is anomaly. So one of the things, like, one of the anomaly detection ideas is like if there are two community, right, and then if there is a cross between them, and then you analyze this community and this community, this shouldn't happen. Like for example, in networks, if you see two regions of like data, and then like you see the connection, you can go and say this never happens. This community shouldn't exist. This is anomaly. Or like this single node, why it's single? Right? There is a computer system that's not connected to almost anything, but it's connected to internet. Why is it even existent? Right? Yes, it can happen and it shows as anomaly. But if there is lots of single standard nodes that not connected to anything else. It could be just there are tons of single nodes there. Oh, back
It's
on.
alive again.
For some reason.
So for the graphs though, like in this particular example, you're defining these edges as relations, but then don't you have to ensure that the units of these edges are the same? So for example, if you're representing like a relationship in terms of like sibling, or if they're siblings or not, then shouldn't that be a single graph, and then another graph would be like relationship between in terms of money transfer? Like, what can you mix?
You can
and
have
match?
attributes still. Like it's not necessarily connection, right?
Okay.
It could be attributes of the edges. And graph is a super complex mathematical concepts, right? And like, let's say I have applied knowledge of it. I'm not like graph mathematician, right? It could be like there are so many things in graph that I don't know as of now. But like one thing Kahal said, that it happens and people do it using graph. But one of my guesses is like using attribution, right? And edges can have many things. It's not necessarily one connection. It could be vector of connections.
And maybe it depends on your algorithm. You might process it one edge feature at a time, or maybe there's some kind of algorithm you have that takes the combination.
Like it gets like edges can be vector of information that gets 0, 0, 0, and then 1 for being sibling.
Right, which is essentially it just all it means is you have multiple graphs overlaid on top of each other in some way using the same nodes.
It's a graph, right? That's how a graph works. So you
Well, yeah, like different topologies for the same
Yeah.
nodes.
Yeah.
Okay.
Okay, like let's go to the hands-on session. Like Will is like everything takes time on that